Today we are going to do lesson 25, solution to equations. So there's two rules when we are solving equations. The first rule says that the same quantity can be added to both sides of an equation without changing the answers to the equation. Meaning, if I add something to one side and I add it to the other, and I add it to each and every single term, Today we're going to be doing lesson 25, solution to equations. So when we are solving equations, there are two rules that we need to follow. The first rule says the same quantity can be added to both sides of an equation without changing the answers to the equation. So basically, if I add something to one side and I add it to the other side of the equation, it does not change my answer to the equation. It keeps it balanced, and that's the biggest thing that we want to make sure that we are doing is keeping our equations balanced and equal, because that's part of what equation stands for. And the second thing says that every term on both sides of an equation can be multiplied or divided by the same non-zero quantity without changing the answers to the equation. So if I multiply or divide on one side, all of the terms on one side, and then I do it to the other side, I'm not changing the overall answer to the equation. I am keeping it balanced. You do it to one side, you have to do it to the other. So for example, if I had 3x minus 2 equals 10. So what I'm going to do is first, I'm going to add. So adding a positive number is what we normally think of as adding. Adding a negative number is what we normally think of as subtracting. So this is what I'm talking about when I say add. So in this case, it says minus 2. So I'm going to actually just add 2 because I want to zero that part out. Add 2. And then I am left with 3x equals 12. Now, my second step is I am going to either multiply or divide so that I can get the x by itself, or isolate the variable is another way to say that. So I am going to divide by 3. If I do it to one side, I have to do it to the other. This actually would reduce down to 1, so I'm left with 1x, so I'm isolating the variable. And then 12 over 3 reduces down to 4. So my answer is x equals 4. Then I can just put that right back in the equation to double check and make sure it works. So 3 times 4 is 12, minus 2 is 10, so it does check out. Okay, so now let's look at some examples. Example number 1 says 4x plus 5 equals 17. My first step is I am going to add a negative 5 or just subtract 5, whichever way makes sense to you. 17 minus 5 is 12. And then I have 4x is what's left on that side. So 4x equals 12. I am going to divide by 4. That reduces down to 1x equals 12 over 4, or x equals 3. The next problem, negative 5m plus 6 equals 8. My first step is I am going to subtract 6 from both sides. And I am left with negative 5m equals 2. Now be careful here. If you have a negative in front of your variable, then you need to be dividing by or multiplying by that negative number to make sure that it is a positive 1 in front of your variable. So in this case, I'm going to be dividing by negative 5, and I do it to one side. I need to do it to both. So that would reduce down to 1m equals negative 2 over 5. All right, the next example, example number 3. Negative 7k minus 4 equals negative 21. So I'm going to add 4 to both sides so that I can start getting that variable by itself, and I can zero out that digit right there. So then I'm left with negative 7k equals negative 17. I'm going to divide by negative 7 so that is a positive 1k. Divide this by negative 7 because if I do it to one side, I have to do it to the other. I end up with k equals 17 over 7 because a negative over a negative is a positive. And then that will make a mixed number of 2 3/7. I have negative 11p plus 5 equals 17. So I'm going to subtract 5 from both sides, and I get negative 11p equals 12. I'm going to divide by negative 11, and I get p equals negative 12 over 11, which equals negative 1 1/11. Sometimes you're going to have to make your denominators the same, but do know that you just need to do like denominators or common denominators when you are adding or subtracting. You don't have to do the ones, the denominators that have to do with multiplying and dividing. So in this case, I'm going to add 1/2, and I would have 1 over 5m, but then this half, I can't do 3/4 plus 1/2. I need to change the denominator of 1/2 to 4 because that is my common denominator. So 2 goes into 4 2 times. 2 times 1 is 2, so 2 over 4. So 3/4 plus 2/4 is 5/4. Now don't make this into a mixed number because we need to multiply or divide depending on the problem. So in this case, we are going to multiply by 5 over 1. We're just multiplying by the reciprocal because we want this to equal 1. So 5 over 1 times 1 over 5 is 1. Do it to one side, do it to the other. So then we would get m equals 5 times 5 is 25. 4 times 1 is 4. 25 over 4 is going to reduce down to 6 1/4. Okay, last example. We have decimals. I have 0.4x minus 0.2 equals negative 0.16. So I am going to add 0.2 to both sides. And I am left with 0.4x is equal to 0.04. I'm going to divide by 0.4. Have to do it to both sides. And then I get x equals 0.1.